Hello and welcome back to our short introduction to SQL. We've previously discussed how we can enter information to a database and define a schema and fill values into tables, and also how to retrieve values. So now we want to look at how we can play with this information a bit more. We can do some in-database analytics, shall we say, where all the data are in the database and we get some new insights. So for example, we can combine tables and match information and then perform some very basic analytics. As a very minimalist example, we can count the entries. For example, select and then the special keyword count star. Everything that's in the table would say select count star from the tables. And in our example, we would get back, for example, 3. The count says how many elements do I have. So the advantage of doing this inside the database is that the database can optimize the queries. Of course, we could retrieve all the information and do this ourselves, but that would mean we would have to copy all the data out of the database, run the analytics to get the answer. To avoid this, some set of analytic functions are inbuilt into the database, for example, like max, min, sum, count, average, and so on. And many databases have their specific extensions. For example, we could say how many samples do we have in a given storage location. So we want to count the number of elements and then give this a new variable name. So we in the end have a table that has a number of items that defines this. In our minimalist example, we need to combine the information of samples in storage, because what we want to do is to have the clear text information. We don't want to handle storage ID as an integer value. We want to see what this corresponds to as a human readable counterpart. So the minimal example is select, because we want to get information out, and now count star, and then we rename this as number of items, and we also want to have the storage location. So these are from two different tables. So we start with count star referencing RDM samples. Then we add the table join RDM storage, and we need to tell the database how to do that, and we link the information via the primary and foreign key storage ID. We can also make this a bit more readable. For example, we can group them by the storage location, so we add all of that per storage location, so we don't have a long list, because we want to use the count one. So the intended outcome is 3 samples in storage location A, for example. So we need to tell the database how to aggregate this information here, and we do this by group by. And in the end, we do this in a sorted list by alphabetically sorting the storage locations. So if we do this, we have now number of items. This is our count star. We have 2 items in one storage location and 1 item in the other storage location. We can add more constraints. We could say we want to have now all the results where we have more than 1 sample. Now it's the same query that we had before. We just tack on having count star greater 1, and you can see that the 1 line disappears where we only have 1 sample in that storage location. Of course, we can build more complex queries. There are many more options, and if you need to, it's better to read up on them as before, just to point you to some of them that you may want to come across. Partition by divides the result set into units, partitions, and then we use the analytics functions on each of those. So for example, the average over columns and other tables. Or you have the lag function that gives you access to previous rows if you want to, for example, calculate differences between rows. You can also use select statement multiple times or subselects, and that gives you access to temporary objects in tables, so it's more convenient to work on those, and so on. The trade-off is, do we do this analytics in database or external? If we do it in the database, all the data are already in the database, and the database engine or server can optimize the queries that you want to take. We have so far discussed very minimalist examples like number or min, max and so on, but you can extend the functionality by sort of store procedures that are little programs stored within the database. We could also do the same thing externally. Then we would have to get the data out. If we do it internal, we are sort of relying on the in-database implementation details. If we do it externally, we have more control over it. In the end, it'll be a trade-off. Speed, memory, but also programming trade-off. How much effort is it to write the analytics you want to write, and how much effort is it to maintain? Now with the database choice you've made, but also you need to think ahead if you, for example, need to migrate to other databases. Again, there is no single best answer to this. You need to sort of weigh up the pros and cons. My personal take is do everything that's easy inside the database, everything that can be done with standardized SQL, some vendor-specific extensions. So that should be relatively easy to migrate to a new system if necessary. Maybe include some but very short store procedures inside the database, nothing that is very costly to re-implement. Of course, you need to sort of stop at the point where it becomes a very complex one. Maybe collect some minimal amount of data for further external processing or some use. And then everything that's more complex is probably best done outside the database and use application code that's agnostic, or at least agnostic as much as possible, to the underlying data storage engine, so that if you need to switch databases and database technologies, it's not so painful to do so.